we will understand very well the systems of linear equations in two variables. Let us look at this example. We have two equations, x plus y equals 4 and x minus 2y equals 1. Now, let's name equation 1 to be x plus y equals 4. And let's use the intercepts to quickly plot the graphs. X-intercept, it implies that y equals 0. So in the equation x plus y equals 4, we will write 0 instead of y. This means that we have x plus 0 equals 4, and therefore x is 4. So the x-intercept is 4, 0. Let's get the y-intercept. Y-intercept means that x equals 0. In the equation x plus y equals 4, we will write 0 instead of x. Therefore, 0 plus y equals 4. This means that y equals 4, and the y-intercept is 0, 4. Let us find the intercepts for the equation 2, x minus 2y equals 1. X-intercept, of course, y equals 0. In the equation x minus 2y equals 1, we will write 0 instead of y. Therefore, x minus 2 times 0 equals 1, and x is 1. Therefore, the x-intercept is 1, 0. Let's get the y-intercept. So for y-intercept, we will write 0 instead of x. Therefore, 0 minus 2y equals 1. And this means that y equals to negative a half. Therefore, the y-intercept is 0, negative a half. Let us have this plotted on the coordinate plane. Remember, from our equation 1, which is x plus y equals 4, the x-intercept is 4, 0, and the y-intercept is 0, 4. And from the equation 2, which is x minus 2y equals 1, the x-intercept is 1, 0. The y-intercept is 0, negative a half. Let's have this shown on the coordinate plane. Let's begin with equation number 1. The x-intercept is 4, 0, and the y-intercept is 0, 4. Therefore, this is the straight line that shows the equation x plus y equals 4. Now let's plot the equation number 2, x minus 2y equals 1. The x-intercept is 1, 0, and the y-intercept is 0, negative a half. And therefore, the straight line that shows the equation number 2 is like this. Equation number 2, it's x minus 2y equals 1. we can see that these two straight lines are meeting at a point 3, 1. Therefore, the solution to the system of linear equations 1 and 2 is the intersection point, which is 3, 1. And therefore, x equals 3 and y equals 1. Let's look at example number 2. In this equation, x plus 2y equals 8, and this equation, 2x plus 4y equals 20, let's name x plus 2y equals 8 to be equation number 1, and 2x plus 4y equals 20 to be equation number 2. Let us get the x-intercept of the equation 1, and this means that y equals 0. In the equation x plus 2y equals 8, we will write 0 instead of y. Therefore, we have x plus 2 times 0 equals 8, and therefore x equals 8. The x-intercept will be 8, 0. Let's get the y-intercept. For the y-intercept, we will write 0 instead of x. Therefore, we have 0 plus 2y equals 8, and 2y equals 8. This means that y equals 4. Therefore, the y-intercept is 0, 4. Let's get the intercepts of equation number 2. In this equation, 2x plus 4y equals 20. The x-intercept will be 2x plus 4y, and we have to write 0 instead of y. Therefore, we have 2x plus 4 times 0 equals 20. And therefore, x equals 10. The x-intercept is 10, 0. Let's get the y-intercept. For the y-intercept, it means that x equals 0. And so we write 0 instead of x. Therefore, we have 2 times 0 plus 4y equals 20. And therefore, 4y equals 20 and y equals 5. Therefore, the y-intercept is 0, 5. Let us have this shown on the coordinate plane. Remember, for the equation 1, x plus 2y equals 8, the x-intercept is 8, 0, and the y-intercept is 0, 4. From the equation number 2, which is 2x plus 4y equals 20, the x-intercept is 10, 0, and the y-intercept is 0, 5. Let us plot equation number 1 on the coordinate plane. The x-intercept is 8, 0, and the y-intercept is 0, 4. So this is the straight line that shows equation 1, which is x plus 2y equals 8. Let us plot equation number 2 on the coordinate plane. The x-intercept is 10, 0, and the y-intercept is 0, 5. So this is the straight line that shows the equation number 2, which is 2x plus 4y equals 20. we can find out that these two straight lines are parallel to each other. And we have to note that in these equations, there is no solution to this system of linear equations in two variables that can make both equations simultaneously true, because the lines of these two equations are parallel to each other. I hope you can understand this very well. Let's go on to example number 3. For this example, we have two equations, that is x minus 2y equals 4 and 3x minus 6y equals 12. Let us name x minus 2y equals 4 equation 1, and we name 3x minus 6y equals 12 equation number 2. Let's get the intercepts. The x-intercepts for equation 1 will be 4, and the y-intercept for equation number 1, of course we know that x equals 0, so we have to write 0 instead of x. So we have 0 minus 2y equals 4 and negative y equals 4. This means that y equals negative 2, and therefore the y-intercept is 0, negative 2. Let's go on to the equation number 2. 3x minus 6y equals 12. Let's get the x-intercept, and of course y equals 0. Now we will write 0 instead of y. Therefore we have 3x minus 6 times 0 equals 12, and therefore x equals 4, and the x-intercept is 4, 0. Let's get the y-intercept, and of course x is 0. In the equation 3x minus 6y equals 12, we will write 0 instead of x, and therefore we have 3 times 0 minus 6y equals 12, and therefore y equals negative 2, and this gives us the y-intercept as 0, negative 2. Let us have this plotted on the coordinate plane. From the equation 1, x minus 2y equals 4, the x-intercept is 4, 0. The y-intercept is 0, negative 2. In the equation number 2, 3x minus 6y equals 12, the x-intercept is 4, 0, and the y-intercept is 0, negative 2. Now you can realize that the x-intercept in the equation 1 is the same as the x-intercept in the equation 2. And the y-intercept in the equation 1 is the same as the y-intercept in the equation 2. This means that we will have the same straight line that shows both equations as shown on this coordinate plane. In this scenario, the solution to the system of linear equations 1 and 2 is infinite. The solution can be any point on the line. This means that the solutions to the system of linear equations 1 and 2 can be infinitely many. So you can really understand the difference between the systems of linear equations. Let us now make the conclusions. Number 1. When the straight lines intersect, it means that the intersection point is the solution to the system of those linear equations in two variables. Look at this equation. That is equation 1, and then we have equation number 2. The intersection point is the solution to these two linear equations. Number 2. When the straight lines are parallel to each other, it means that there is no solution to the system of those linear equations in two variables. Take a look at this. Look at equation number 1 and equation number 2. These two equations are parallel to each other, and this means that we don't have the solution to this kind of system of linear equations in two variables. Number 3. When the straight lines are equivalent to each other, it means that the solutions to the system of linear equations in two variables are infinite. Take a look at this graph. We can see that equation number 1 and equation number 2 have the same straight line, and this means that the solutions to these two linear equations in two variables are infinitely many. Therefore, a system of linear equations in two variables can have one solution, infinite solutions, or no solution at all.